Okay. In this seminar, we're gonna do Form 4 Chapter 6 Sorts. Okay. The reason why we want to do sorts is because sorts is a very long chapter, as you know. We need a lot of time to do revision for sort. Okay. So which is something we can't do it normally in the class. Normal class only got 1 hour, right? So there's not enough time to do sort. So we can only do it in seminar. This is the reason why we cannot do like chapter 1 revision or like other chapter, okay? So let's look at page number 2. So page number 2. So let me tell you what. To do well in sort, okay, to do well in sort, you have to always memorize, okay? To be honest, very honest, yes, you have to memorize these 5 major parts. First one, solubility of salt, okay? You have to memorize, you have to remember what type of salt they are soluble, what type of salt they are insoluble, okay? After solubility, it is the preparation of salt. You have to know how to prepare salt. How to prepare salt, which is like method, what's the method to do it, and then what are the reactants needed. That's what you have to know for preparation of salt. And then, it is the color of salt. You have to be able to tell what color is that salt, and then you have to know how to do the heating of salt, and finally, the ion test. Okay, so if you're not very good with salt, you can always start with the front 4 parts, the first 4 parts. If you can do solubility, preparation, color, and heating, actually you should be able to answer 1 question already, almost a complete question. Okay, when you know how to do these 4 parts already, then only you move on to the ion test. Okay, so let's start with the very first part, solubility of salt. So look at this table. So this table tells you what kind of salt they are soluble and what kind of salt they are insoluble. First, we have this SPAN, which we call it at, give me a second, so which we call it the span salt. So every time you see span, they are soluble. Span is sodium, potassium, ammonium nitrate. Sodium, potassium, ammonium nitrate. That means every time when you got a salt, right, and you want to tell the solubility, you should always ask yourself, okay, can I find sodium, potassium, ammonium, or nitrate in the salt? If yes, then soluble. All right. If there's no span, then we will move on to the second group, which I call it the COOH. COOH is like, okay, you have to see the salt got CO or not. CO is like carbonate. The salt got OH or not, hydroxide. Okay, or the salt got O or not. Got O or not, okay, oxide. So COOH, got CO, got O, got OH. So they are all insoluble. Okay, here it says except SPA. Actually, I think it's not important to remember that it is except SPA, as long as you follow this. Okay, as long as you follow the sequence, okay, follow the sequence. For example, if I give you Na2SO4, a salt like this, we should always go with the first group, span. Do I have sodium? Oh, yes, I have sodium. Then straight away, soluble. All right. Okay, another example, CaCO3. Then I ask myself, does it come with span? Sodium, potassium, ammonium, nitrate? Okay, no. Then I move on to the second group. Does the formula have COOH? Oh, obviously it has CO. Then insoluble. Understand? Okay, Then when I have Na2CO3, I do the same thing. Does it have span? Sodium? Oh, yes. Straight away a tick. That means we always prioritize. our span first. If there is span, we prioritize the span and it is soluble. All right, Kenya. Next, last one. If there's no span, no COOH, then only we go for the chloride or sulfate. Chloride, we call it as roti canai. C for canai. Why do we call it as canai? Because chloride salt are mostly soluble. They are soluble all the time, except for PB, AG, HG. We call it the persatuan, argama, Hindu. When persatuan agama Hindu pair with the roti canai, it is insoluble. Okay. If sulfate called as a siu bao. Siu bao is basically a non-halal food. Okay. So it is per PBBACA, we call it as Persatuan Bahasa Cina. Persatuan Bahasa Cina. So that means when Persatuan Bahasa Cina is paired with Silbao, they are insoluble. If Persatuan Agama Hindu is paired with Roti Canai, they are insoluble. So everything here, they are insoluble. Understand? And please remember that China is CA, yeah? It's not CU, it's CA. All right? Can you all understand everything here? I say, if yes, can you please say okay? Are you okay with the solubility of salt? Okay, all right, okay. Then next, I'm gonna ask you some questions. So you have to tell me whether the salt is soluble or not. Yeah. Is there any empty space? Okay. Yeah, I use here. If the salt is soluble, you type 1. If the salt is insoluble, you type 2. Okay, first example, we go with BaCl2. Is this soluble? Soluble 1, insoluble 2. Soluble or insoluble? Faster. Okay. Yes, okay, see. So as I said, every time you have to check group by group. Does it come with span? You have to ask yourself. This is something you have to ask yourself. Sodium, potassium, ammonium, nitrate? No. Does it have COOH? No. Oh, it's chloride. Is it pairing with persatuan, agama, Hindu? Is the chloride pairing with persatuan, agama, Hindu? No, it's not. So the salt is soluble. So it's 1. Okay, no, guys. Understand? For those who got the wrong answer, can? Okay, then next one. If I have CuSO4, soluble or insoluble? Yes. Okay. Good morning, guys. Hopefully you are listening, okay? And understand what I say. Okay, see. So we check with the span one. Do we have sodium, potassium, ammonium nitrate? You have, okay, you're not very good with salts. You cannot temper on, You have to like really go through sodium, potassium, ammonium nitrate. No. COOH? No. Then only the sulfate. Okay. Sulfate cannot pair with persatuan bahasa Cina. Okay, just like I just told you, Cina is Ca, is not Cu. So this one is Cu, obviously. Soluble. Okay or not? Okay, then next one, Okay, next one. Ag2SO4, soluble or not? Okay, yeah, thank you. So, sodium, potassium, ammonium nitrate, no. COOH, no. It's a sulfate. Is it pairing with persatuan bahasa Cina? No. Soluble. Only when the sulfate is paired with PBBACA, they are insoluble. If it is not with these three, they are soluble. Just like that. Last one. K2CO3, soluble or not? Okay. Okay, good. Okay, see Oi, listen to what uncle said. Okay, go through one by one. Don't simply tempa. Don't simply when you see, you see Cl, then you start tempa. Go through one by one. Sodium, potassium, ammonium nitrate. Sodium, potassium. Oh, potassium. Soluble. Just like that. Just like that. Okay? We prioritize the span first, then only the COOH. You can't see CO, then you say insoluble. Okay, Okay. Now, at the bottom, there are 40 questions. I need you to answer all these 40 questions. If it is soluble, you put a tick. If it is insoluble, you put a cross. Okay, let's do these 40 questions. Once you're done, let me know. Once you're done, you just say okay. Okay, I will be giving you guys 3 minutes to do this. Okay, 3 minutes. Done. Okay, good. Okay, we have another 1 more minute. Okay, some of you have done the question already. Nice. Last 30 seconds. Okay, time's up. So the first one, so remember what I said, always we go for span, okay, and we ask ourselves, does it have sodium, potassium, ammonium, nitrate? Okay, no. Does it come with CO, OH? CO, yeah, CO, insoluble. For the insoluble one, I do it like this, okay. It's soluble, I put a tick, insoluble, I do it like this, okay. Sodium, sodium, soluble. Sodium, potassium, ammonium, nitrate? No. COOH? No. Chloride or sulfate? Or sulfate. Is it paired with PBBACA? Oh yeah, Ca. Then insoluble. Sodium, potassium, ammonium, nitrate or nitrate, soluble. Just like that. Very simple. Potassium, soluble. Cl, pairing with persatuan, persatuan agama Hindu? No, soluble. Sodium, soluble. Ammonium and nitrate, soluble. No span, no COOH. And it is SO4 not pairing with PBBACA, soluble. Cl is pairing with PB. Roti canai is pairing with persatuan. So it's insoluble. No span, but it comes with CO, insoluble. Nitrate, soluble. Sodium, soluble. Silver and chloride. Roti canai is paired up together with the agama. So it's insoluble. Siu bao is paired with persatuan, insoluble. I see nitrate, soluble. Ammonium, soluble. Roti canai is paired with the H Hindu, okay? Soluble, insoluble. I see sodium, soluble. I see sodium and nitrate, soluble. Is everything okay on the left-hand side? For the left-hand side, okay, right? Any question? If you have any question, please ask, guys. It is very important. Salts is like that one. Just like the carbon compounds, the chapter 2 we are doing right now. If you can't do solubility, there's no way you can proceed to the next one. Only when you know how to do solubility, you can go to the next topic. You cannot say like, okay, I think can lah, maybe can. You have to make sure you can, then only you can go to the next topic. Okay? Okay, no one has question to ask me, then go next. I see carbonate without span, so it's insoluble. I see potassium soluble, ammonium soluble, nitrate soluble. I see carbonate without span, insoluble. I see chloride not pairing with persatuan agama Hindu, soluble. I see sulfate pair with siu bao pairs persatuan bahasa, insoluble. Potassium nitrate, soluble. I see carbonate without span, insoluble. Roti canai is not pairing with persatuan agama Hindu, soluble. Siu bao is not pairing with persatuan bahasa Cina, soluble. I see nitrate, soluble. I see carbonate without spa, insoluble. I see ammonium, soluble. Nitrate, soluble. Siu bao not pairing with persatuan bahasa Cina, soluble. Carbonate without spa and without span, insoluble. Roti canai is not pairing persatuan agama Hindu. soluble. Silpao is not pairing with persatuan bahasa Cina, soluble. I see nitrate, soluble. Just like that. Any question? No, Okay, done. So we have done with our very first part, the solubility of salt. Okay, Okay, so this one done. Moving on to the next one, preparation of salt. Okay, this part is like one of the longest part. Okay, it's like the second longest compared to the ion test. Okay, so let's look at the following page, number 3. Prepare salt. So in preparation of salt, you have to know preparation of salt. Most of the time, they can come out in essay and they want you to write a procedure. Like, okay, tell me how you prepare the salt. In order to be able to give the correct answer, actually the procedure, the steps, how you do it is not that important at first. The first most important thing should be the reactant. You must know how to find the reactants first. There's no point memorizing the procedure without knowing how to find reactant. Okay, some students say, oh, my teacher gave me tips, I have to memorize this one. They memorize, they go in, they write, they cannot get the marks because their reactants wrong. Okay, reactant is like ingredient. If you want to make something, you must get the right ingredient. Let's say I want to make let's say I want to make roti canai. I should maybe buy some flour. I should maybe buy some eggs as my ingredients. Okay. If I bought the wrong ingredients, I want to make roti canai, and then I decided to buy some a pencil, buy some chairs. Can I make roti canai? Cannot. So yeah, reactant is very important. Then if you can get the reactant right already, then only we talk about the method, which is like procedure, or how we do the experiment. How do we handle the ingredients? Okay, so now, the first part, I'm going to teach you how to find the reactant. So this is how you find reactant. Can you see this chart here? We always start from the salt. Okay, let's say if I want to make NaCl. I want to make sodium chloride salt. What are the ingredients needed? So this is how I do it. So we start from salt here. Okay, NaCl is the salt I want to make, I want to produce. Then I start asking myself, is NaCl soluble or insoluble? So guys, left or right, soluble or insoluble? This salt I want to make is, yeah, very good, soluble, correct. So it comes to the left-hand side. Okay, when it comes to the left-hand side, there are two types of soluble salt. We can have soluble spa salt and soluble non-spa salt. Okay, what is spa? Spa is sodium, potassium, ammonium without nitrate, yeah, without nitrate. Spa only, no N, no N. Not sodium, potassium, ammonium, we call it as non-spa salt. So you have to ask yourself, my NaCl contains spa or no spa? Obviously, there is sodium here, right? Na is sodium, so spa salt. So it goes to the first method here. Like that. Tring. Okay, understand? Okay. Then next, if I want to make zinc sulfate. So is zinc sulfate soluble? Zinc sulfate soluble or not? Nice, soluble. Does it come with spa or no spa? Yeah, very good. No spa. There's no sodium, potassium, or ammonium. So it comes to the second one. Thing like that. So you have to know how to differentiate the type of salts first. Okay, we don't care about how they do it. Yeah, one more. Okay, let's go with PbNO32. Soluble or not? Soluble or not? Okay, yes. Okay, very good. Soluble? Spa? No spa? Okay, very good. No spa. Ta-da! This one. Okay, good. So this is how you differentiate the type of salt. Okay, and then now, how to find the reactant? If I want to make NaCl salt, you can see, they say, oh, we are using neutralization to make this kind of salt. Okay, neutralization is a reaction between acid and alkali solution. So when I'm making this NaCl, definitely I would need an acid, I would need an alkali solution. So this is how you do it. We always call it as the three different cross. We use cross to find reactant. First, we put the salt that we want to make into the cross, like this. Split it into two ions, guys. So Na plus Cl minus. Okay, you all can write down this one first. We split the salt we want to make into two ions. So whatever you want to get in the end, you put it into the cross. I want to get NaCl, I put NaCl into the cross. And then we need an acid and alkali to make sure that our reactant is an acid and alkali. On top of the cross, we write OH minus H plus. OH minus is alkali solution. H plus is acid, right? So all I have to do next is just pair the ions up together. Left side pair with the left side. Na plus and OH minus, we get NaOH. So this is my reactant 1. And then H plus Cl minus, I get HCl. This is my reactant 2. Yeah, understand? So this is our very first cross. OHH for the soluble spa salt. Okay. Reactant, okay, see, if I write an equation for both of my reactant, can I really get the salt that I want? NaOH plus HCl, yes, I can get NaCl and also H2O. So you see, with the right ingredient, I can get the salt that I want. Understand? Okay, is everybody okay? Okay, okay, then next. Okay, next one. Let's say I want to make lead-2 nitrate this time. So to make lead-2 nitrate, I put the lead-2 ion and nitrate ion into the cross. So to make this type of salt, they say, we can undergo reactions like, okay, we can have reaction like acid with reactive metal, acid with metal oxide, or acid with metal carbonate. So I'm going to call them as COOH, H plus. Okay, why is it COOH? Because CO is carbonate. So my lead can pair with carbonate. O is oxide. So lead pair with oxide. OH is hydroxide. So the lead can also pair with hydroxide. So there are a lot of options here for the soluble non-spa salt. And I highly recommend you to use carbonate and oxide. I think oxide is the easiest one. Beginner friendly, okay? I will always ask you to avoid using the hydroxide one. Okay, why? Okay, because I know students like to create their own shortcut. Like, oh, this one can use OH. This one can use OH. Wait, that is the same as the first one, no? Then both also I remember OH and H plus. Easier. Soluble salt, I just use OH and H plus. This is actually very bad because the people who setting the question, they know. They knew it. You're going to do that. So they are not going to let you use the OH minus. That means the option, right? They are not going to give you the OH. Okay, so when you don't see the OH, you start panic. Oh my God, oh, why there's no OH? So always go for everything. You have to know everything, COOH. Okay, they like to come out with carbonate. They like to come out with oxide. Okay, so I want you to start sticks with carbonate and oxide. Don't use the hydroxide for now. Okay, that's all for the soluble non-spar salt. Okay, can we try? Okay, I will be giving you some salt now, and you have to tell me the reactant. The reactant, Okay, you only have to give me one. Just give me one. Okay, we try, we just try with the zinc sulfate salt we want to make just now. If I want to make zinc sulfate salt, guys, zinc sulfate, what are the two reactants needed to make zinc sulfate? Okay, I show you how to type the answer. Oh, yeah, correct. Very good. Nice one, Hong Liang. Like the lead 2 nitrate just now, my answer is PbOHNO3. You can straight away type like this. Without the capital letter, it's okay. Ziling, thank you very much. So to make zinc sulfate, what are the two ingredients needed? The two reactants needed? Hello? Okay. Thank you, Derry. Okay, never mind. We don't have much time left. We can't just wait here. Okay. So zinc sulfate is, thanks, Natalie. Very good. Okay. To get the reactants for soluble non-spar salt, first we put the ions into the cross. Then on top of the cross, it is COOH H plus. So I use the easiest one. So everybody use the easiest one. Oxide, zinc oxide, H2SO4. That's how you get the reactant. And that is the answer that I want. Okay, just like that. Okay, moving on to the next one. The insoluble salt. Let's say I want to make silver chloride. Okay, roti canai pair with the persatuan agama, Okay, so this is insoluble. So insoluble salt, okay, insoluble salt, we're going to use this type of cross. Same thing, I want to make AgCl, so I'm going to put AgCl into the cross. Ag plus Cl minus. Just like that. Okay, then what should be placed on top of the cross? So this part, it says the insoluble salt is produced from double decomposition reaction. Double decomposition reaction means you are going to mix two soluble salt solution together. Soluble plus soluble, and then we get an insoluble salt. Soluble and soluble gets insoluble salt. This is what we call double decomposition reaction. So we have to make sure that our reactants is always soluble. To make sure that our reactant is always soluble, we can pair them with N-SPA, which is our SPM. But I put the nitrate in front to pair with the Ag+. Okay, we are using SPM because we know anything that pair with SPM will be soluble. So that means if silver pair up together with nitrate, silver nitrate will be soluble. Okay, SPA is sodium, potassium, and ammonium. We can use any one we like. If you like sodium chloride, use sodium chloride. If you prefer potassium chloride, then go for potassium chloride. So that's how we get the reactant. Okay, so there's no need to write two. You just write one is enough, like NaCl, just choose one. That's all. So these are the three different cross to find the reactants for different type of salt. Can you all understand? Yes, huh? Okay, then now I'm going to give you a few examples. You have to tell me which cross to be used. Cross number 1, number 2, or number 3. Okay, so the first salt that I want to make is the potassium sulfate salt. If I want to make potassium sulfate, I should use the first cross, second cross, or the third cross. Okay, very nice. Correct. Potassium sulfate is soluble and it comes with SPA. So this one. Okay, then if I want to make calcium carbonate, first, second, or third. Okay, yeah, calcium carbonate is insoluble, very good. So we're going to use the third one, like this. Okay, last, if I want to make magnesium chloride, it must be the, yeah, second one. Okay. Since you know how to differentiate the types of salts already, now you have to give me the reactant. Okay, just 3 examples will do. So first, start with K2SO4. Please tell me what are the reactants needed to make K2SO4. Okay, give me the 2 reactants needed to make K2SO4 by using the first cross. Very good. Nice one. So to make the K2SO4, we split it into K plus SO4 2 minus with the cross OHH. So I get KOH, I get H2SO4. So this is my answer. Okay, then now second, if I want to make magnesium chloride, the 2 reactants are Nice. Okay, good. Mg2 plus Cl minus with the cross COOHH. So this one use oxide, we use HCl. That's all. Last one. So the last one, nice. Good. Thank you very much. Ca2 plus CO3 2 minus. So we use the cross and spark. Very good. Calcium nitrate. Okay, we can use sodium or potassium carbonate, anything lah. Okay, so let's say I let's say in the lab, I can't find calcium nitrate. I can only find calcium chloride. Can I use calcium chloride to replace my calcium nitrate? Can I use this calcium chloride to replace the calcium nitrate? Hong Liang, very good. Can we? Okay, can use calcium nitrate or not? Calcium chloride or not? You have to ask yourself. Is it soluble? The reactant that we use here must be soluble. It doesn't have to be like nitrate 100%. I give you N spa here, it's just like a guideline. So there is something you can follow. You can get the reactant more easily. But then if you doesn't want to use the N spa, you can just give me anything soluble. Calcium chloride, is it soluble? Yes. Then it can be used. Okay, understand? So if I doesn't want to use calcium chloride, can I use calcium sulfate? I don't want to use calcium chloride. Can I use calcium sulfate? Very good. Cannot. Why cannot? Why cannot? Why cannot? Yes, because calcium sulfate is insoluble. Yeah, very good, like that. So this is how you find the reactants. Okay, you can write down anything that you think is important down. If everything you know how to do, then don't have to write down. If you are good with everything here, no need to write down anything. Not needed. Come. Just like that. Yeah. So now I have to go through the method a bit. Okay. For those who never answer my question, I don't really know you can do it or not, but mostly I think some of you cannot do now. Okay. You'll just sit here and listen and you cannot understand. You still sit here and listening. I don't know why. Okay. So now I go through a bit of method. For those who can understand, okay, now we can move on to method. Then we can write essay question. But too bad there's not enough time to do essay today. But we will definitely do the essay question in class. One day lah, okay? Before your SPM maybe. Okay. So here guys. For the first type of salt, soluble spa salt, we can look at the page number 4. Here is like the procedure, the steps to make soluble spa salt. To make soluble spa salt, can you see? We are using this method here called the titration. So there is a name for this method. It is called titration. That means we don't just simply add acid into the alkali solution. We have to use this apparatus and we add the acid drop by drop into the alkali solution until it is completely neutralized. But how do I know that the acid and alkali that has completely neutralized? This is why we need phenolphthalein indicator. So we will add acid until the phenolphthalein turns from pink to colorless, then we will stop adding acid immediately. Okay, and here comes a very important steps, guys. Can you see? So after I did all the steps here, it turns from pink to colorless already. Here is the most important step. Which is the step that most of the students they will forget. Which is we have to repeat the experiment without phenolphthalein. So the first few steps here we did is actually just to get the volume. Okay, all these steps we did here is just to get the volume of acid needed. I do this is to find out, okay, how many cm3 of acid is needed. Let's say, oh, I know already it's like 25 cm3. I found it. And then I got to repeat my experiment. Same thing, but without the phenolphthalein. Why? Because if you have phenolphthalein together in the salt solution, then the salts you make will not be pure. You want to make a pure salt. You doesn't want to have any impurities inside. You doesn't want to eat salt with phenolphthalein chemical inside, right? Yeah. So you have to start again without phenolphthalein, but with the same volume. So let's say I found that it's 25, then I use 25. I just add 25 cm of acid into the alkali that I stopped. Understand? If you all can understand, you'll say, okay. Okay, can the phenolphthalein is an indicator to tell you when to stop adding acid. Because if it doesn't have phenolphthalein, the things doesn't have color, right? We don't know whether it is now, it is still alkaline or it is already neutral. So we need phenolphthalein to show the color change. Color change tell us when the neutralization happens. Okay, good, thank you. Okay. After we have done all this, we get the salt solution. Acid plus alkali, we get salt and water. So what are we going to do with the salt solution? These are the 5 important steps. We call it as hypo can fly really dangerous. Hippo can fly really dangerous. Okay, what is hippo can fly really dangerous? Hippo start with the letter H. H means we have to heat. We have to heat the salt solution we got to actually evaporate the water. It's like seawater. I want to turn seawater into salt, solid salt. What do? I evaporate the water. By heating it, we speed up the evaporation process. So we have to heat the solution until 1/3. I have to write 1/3 of its original volume to obtain a saturated solution. Okay, we heat it until 1/3 of its original volume. That means at first like that, I heat the water will evaporate, gets into 1/3. And now it becomes a saturated solution. It's like very, very concentrated. Okay, then we can start cooling the saturated solution for crystallization to occur. That means when it's cool to room temperature, it starts forming crystal, solid. Okay. Then we're gonna filter the salt crystal out and we rinse it with distilled water. So the crystal forms are filtered and rinsed with a little distilled water. People can fly really. Lastly, dangerous, which is dry, the solid salt. These 5 important steps, these 5 steps are very important because it can always give you 4 to 5 marks for your essay. One essay to prepare salt is always like 10 marks. Okay, the first 5 steps in front give you 5 marks. Another 5 steps here to give you another 5 marks. If you forgot all this thing already, you forgot that you have to use titration now, you have to use phenolphthalein, have to repeat. Never mind. If you can still remember to write these 5 steps, you can still get 4 to 5 marks. Okay, can okay, just like that. So don't give up. Forgot this part already, never mind, write the final part. We can also get the marks. All right, next. Moving on to the page number 6. This is soluble non-spa. Okay, why do I have to explain until so details? It's because this year, salt most likely will be coming out in essay. So you have to be prepared. Okay, so number 6, soluble non-spa salt. This is how they do it. They don't use titration. There is no specific method. There is no name for this method because we are just adding the things into the acid directly. We just add directly. There's no specific method. But one thing very important here is we have to add point 3. We have to add excess copper 2 oxide powder. The oxide that we found from our cross has to be added in excess. So you see, we add copper 2 oxide powder gradually into the acid until it can no longer dissolve. We add a bit, we stir, we add a bit, we stir, we add a bit, we stir, until it can no longer dissolve. Why? This step is to make sure, write the reason here, is to ensure the acid is reacted completely. Okay, you can write down this one, it's important. It is to ensure the acid is reacted completely. Okay, you write down first. I draw my diagram. Okay, so I have a beaker of acid here. Wait, screen lagging. Lagging. Okay, back. So this is my nitric acid in the beaker. And then in the beaker, acid, right? There will be a lot of hydrogen ion. So hydrogen ion represents acid. So when I add my copper 2 oxide into the acid, the H plus will start reacting. Copper 2 oxide is a solid, guys. The oxide carbonate, because they are insoluble, right? COOH, they are insoluble. COH, they are insoluble, so they always exist as a solid. This is also the reason why we cannot use the same method as the titration here. Titration has to be both liquid. This one is a solid, that's why we have to use another way to do it. When I put the CuO into the beaker of acid, the H plus will start reacting with it. So let's say this CuO I have added is enough to react with 3 hydrogen ion. Okay, then no more CuO. The CO finished ready. Then if I still have extra acid in the beaker, that means the acid will actually mix with the salt produced. When acid mix with the salt produced, then our salt is not pure. So we doesn't want a salt that tastes salty at the same time acidic, right? So we have to add a lot of CuO, excess CuO, to make sure all the acid will be reacted completely. So no more acid in the beaker, but I have excess CuO, extra CuO that is not reacted yet. Then how? We can just filter it out because it is a solid. We can filter it out very easily. So inside will be left with salt. Okay, I show you the equation. HNO3 plus CuO. So the H and the O forms water. Copper and nitrate forms copper 2 nitrate salt. So this is my salt and water. So as I said, extra CuO has to be filtered away. So this is why this step is also important. The unreacted copper 2 oxide is removed by filtration. Then it's the same thing again, which is hippo can fly really dangerous. Can okay. Last. Okay. After this, we take a short break. Last ready. Page number 8. Insoluble salt. Okay, insoluble salt. The reaction is called double decomposition reaction. The method can be known as precipitation. So this one has a method. Precipitation. So here, what are we going to do? We have to mix 2 soluble salt solution together. Just mix the solution together, and then it starts to produce precipitate, which is the solid salt. Once I got the solid salt, I just filtered it out. Filter, rinse, and dry. So this one doesn't come with hippo. It straight away is filter, rinse, and dry. Reason is because when you are using soluble salt solution, okay, to get an insoluble salt, you can see all these are soluble, soluble, soluble. Soluble means they are all solution. So there's only one thing exists as solid here. The rest are all solution. Then we can just filter it out. It's like my water got sand now. Inside my water got sand, insoluble salt. I just filtered it lah. Then I can get the solid I want. All right, that's all. Let's take a short break. I give you all a 4 minutes break. Come back later. Bye bye. See you. Hi, welcome back. Okay, so let's continue. Okay, let's continue. We are done with the preparation of salt already. Now is color and heating. Color and heating we can done in 5 minutes. Then we can start doing questions already. Okay, once we finish with color and heating, we can start with our color. I mean, start with our question. With our color block. Okay, we look at the page. Yeah, number 10. Color of salt. Okay, color of salt. Yeah, you have to memorize the color. No choice. Fe2 plus is green. Fe3 plus is brown. I believe everybody knows that. Okay, in the chapter 1, we also did quite a lot of Fe2 plus and Fe3 plus, which is green and brown. Cu2 plus are mostly blue. Cu2 plus are mostly blue. Okay, I want you to remember that Cu2 plus is always blue, except for CuCO3 and CuO. How about the CuCl2? Okay, see, CuCl2 is here. This is from the textbook. Okay, CuCl2, it is green in the solid state, but blue in a solution. That means it is a green solid. After it dissolves into water, it forms a blue solution. So most of the time, when we are using copper 2 chloride, it is actually already in a solution form. So that means it will also be blue color. So if you ask me, should I remember green or blue? If you ask me which one better, of course blue. Because most of the time we see CuCl2 in a blue color form. Less likely we see it in solid. Even the product produced is also a type of solution, so it's blue. Okay, so go with blue, and if you can remember that the color is green in the solid state, it's better lah. But if you have to choose one, then go for blue. So everything is blue except for Cu, CO3, and CuO. Okay, since we talk about this, please remember there is a difference between Cu2 plus and Cu. Copper 2 ion is blue in color. But copper metal is brown. So there is a difference. So when questions ask you, hey, what is the color of copper? Don't tell them, oh, blue. That's copper 2 plus. Copper is brown. All right, okay. So other than these 3 main salts, most of the rest, the rest of the salt mostly are white color. Okay, then here comes the very important one. Must always remember the color of PbO, ZnO, and PbI2 because they got special color. Questions will always come out salts with special color because they want you to find the identity of the salt. So they have to give you some clue. They have to give you some hint. By telling you that it is brown when hot and yellow when cold, people will straight away know that it's PbO. But if they say, oh, the salt is white, wow, got so many white salt, zinc chloride, zinc sulfate, zinc nitrate, they are all white. Magnesium chloride, magnesium sulfate, magnesium nitrate, all white. Which one should I write? Okay, so they always go for the salt with special color. Lead 2 oxide, PbO, is brown when hot, yellow when cold. We call it as the peanut. P for peanut. If you agree, then you can use this use this example to remember. The color of the peanut, okay, like the nasi lemak peanut, the skin, the outer appearance is always brown in color one, because they fried it already. Okay, after goring it, it becomes brown color, so it's like brown when hot. Okay, before goring, or maybe the inside, after you peel off the skin, inside is like a bit yellowish. So we call it as brown when hot, yellow when cold. So peanut, brown when hot, yellow when cold. Okay. Then zinc oxide is yellow when hot, white when cold. Yellow when hot, white when cold. Yeah, it looks like a banana. Some of them say it looks like banana. Skin is yellow, but inside, they call it as white. It's actually lighter yellow, light yellow color. But yeah, it looks like, they say it looks like white. So you can use this method also. Okay, if you doesn't want to use this, which I personally, I don't use this. Last time I used to use this one. These three oxide are the most popular exam question. Starting with copper 2 oxide with black color. That means it starts with the darkest color. Darkest color. Then it's like when I buy a pencil, a color pencil, it starts with the darkest color, black. And then the next color group, okay, not gray. Gray is like the same color group. It's just that black becomes lighter. So next color group, beside the gray color or beside the black color, will be brown. Okay, and then for me, brown color, the next color group, similar to brown. Okay, you can say orange, but here we have to remember there's yellow. So black, brown, yellow. Zinc oxide is yellow when hot, then white when cold. So from darkest color to lightest, black, brown, yellow, yellow, white. If you write this every day before you sleep, for a week, for sure you can remember one. So when it goes to the exam, you just write this out, then you can refer already. Okay, like that also can. Or if you want to go from lightest to darkest color, it's like fried chicken. Fried chicken. Let's say I work in the KFC. So it started off with a white chicken because it's coated with powder already. So it's white. And then when I put it into the oil and fried it, the white chicken will slowly turn yellow. Okay, right? Golden yellow. And then if you fry it longer, the yellow will start to turn brown. The chicken turns brown. And you fry it until the whole thing is burnt, that is black color. So white, yellow, brown, black also can. Okay, just like that. Please remember that PbI2 is yellow in color. PbI2 is yellow in color. Okay, just like that. For those who can already do very well in chemistry, you can also remember that lead-2 chloride and lead-2 iodide, they are soluble in hot water. We know that PbCl2 and PbI2, they are insoluble. Normally, they don't dissolve into water, but it is hot water, they will dissolve. Because sometimes objective, they might ask you which of the following salt can dissolve in hot water. Okay? Next, last one, heating of salt in the page 11. Heating of salt. Okay. The two most important one is heating of carbonate salt and heating of nitrate salt. When we heat a salt, please remember, when a salt is being heated, it will always produce a residue and gas. Residue is usually metal oxide. Residue is metal oxide. So heating of salt will always get you metal oxide and gas. So let's look at this. When we are heating a carbonate salt means it can be anything carbonate. If I'm heating zinc carbonate, zinc is the metal, right? So you see, zinc oxide, metal oxide. Then the parts at the back, it produces the gas. It decides what gas to be produced. If the salt is CO3, it will always produce CO2. Okay, and they both look similar, right? Yeah. So carbonate produce carbon dioxide. It is like, okay, something like this. We give an O to the zinc already. So we got 2 O left. You can remember that way. Normally, questions, they gave you things that's at the back, and you have to tell them what is the salt. So that means you have to know how to combine these two things together and get back the salt in front. Okay, so zinc oxide gives you the zinc ion, say N2+. CO is similar to carbonate ion, so it's zinc carbonate. That's all. For nitrate salt, it's the same. Front part, it gives you the metal. And the part at the back tells you what gas will be produced. Okay. So zinc produce zinc oxide. And then if you still remember, at CO3 produce CO2 just now. Now this term is NO3 produce NO2. We're just changing the C to N. NO3, NO2. But you have to remember the NO2 will comes together with O2. Because you can see that this compound is slightly bigger than the one just now. This one got bracket, wow, still got more atoms. So that means when it decomposes, when the salt is being heated, it decomposes. We can also call it as decomposition reaction. It breaks down into NO2 and O2. Okay, a bracket here is like another 2. Just like that. So if you see a question, guys, they say salt X is being heated, it produces a residue, gas A and gas B. When you see 2 gas are produced together, the combination must be NO2 and O2. Confirm. If it only produces 1 gas, it is CO2. So we can also use the number of gas they produce from the reaction to know the identity of the salt. Okay. To differentiate NO2 and O2, please remember NO2 is brown in color. In this salt chapter, there's only one type of brown gas, NO2. When I see brown gas, confirm is NO2, confirm. Now we can start doing questions already. Finally, done. Okay, now please go to the question. We start with H. This one, 23. A salt structure or assay, very often they will come out a chart like this. You have to be able to solve the chart in order to answer the questions below. Okay, so when you are doing a chart, right, remember, if the questions wants you to find reactant, if they want you to find what is the reactant, remember to use the cross. Finding reactant, remember, in the preparation of salt, we use cross. If they want you to find products, then we will write equation. We use equation to find product and we use cross to find reactant. Okay, let me show you. We have zinc chloride reacting with solution S. It forms zinc carbonate and solution T. So from this part, they told me that this thing and this thing forms zinc carbonate. So the solution S is a reactant or product, R or P. The solution S they want me to find is a reactant or product. Yes, it's a reactant, right? So I have to use a cross. Okay, I have to use cross to find the solution S. And then remember, we put the cross on the product. Whatever sorts you want to make, you put a cross on top of it, like what we did earlier on. I want to get zinc carbonate, I put a cross on zinc carbonate. So zinc carbonate, soluble or insoluble? Soluble or insoluble? Thank you. It's insoluble. Insoluble, so we use the N-spa cross. So I'm going to get zinc nitrate, and it can be sodium or potassium carbonate. So I have two reactants here. Which one is the answer they want? You look at the first one here, zinc chloride. Zinc chloride already has zinc. So we don't need this part anymore. So all we want is the carbonate part. So the answer is K2CO3. Understand? Okay. And then to get the solution T, which is a product, whatever the arrow is pointing at is the product. To get the product, we write equation. You see, we get zinc carbonate and KCl. So that's what I mean by we use equation to find product and we use cross to find reactant. Okay. Next, solution U. We already got zinc carbonate reacts with acid to find the product. So find product, we write equation again. Zinc carbonate with nitric acid. We get zinc nitrate, water, and carbon dioxide gas. So zinc nitrate is the answer. Water, carbon dioxide gas. So that's how I found the unknowns. Only when you can solve the chart, you can answer the question below. So here it says, state the solubility of zinc chloride salt. Okay, yeah, this one is soluble. Identify S, T, and U. We got all the answer already. S, T, and U. Type of reaction for step 1. This is a reaction to make insoluble salt, right? Do you still remember what is the reaction to make insoluble salt? What's the reaction to make insoluble salt? Yes, DDR. Our double decomposition reaction, correct. Very good. Okay, you see? A balanced equation, you see, we can like answer most of the questions. The diagram, diagram is like a different, a special one. How the colorless gas can be tested. To test carbon dioxide gas, we have to bubble the gas into lime water. So you have to know how to draw a test tube. that contains lime water, and usually we draw it like that. Okay, so this is the gas W, is it? Yeah. So you bubble the gas W into a test tube containing lime water. That's how you test it. Done, the whole thing. Okay, next. I think we can try this one, page 30. Page 30. Page 30. So I want you to try yourself and find me all the unknowns, please. Solid P, gas Q, reagent U, solution R, solution S, solution T. Okay, you try your best to find all the unknown first. Then we will discuss later. Once you're done, you just say okay. Okay, once you're done, you say okay. Done. Okay, very good. Once you're done, then Ziling, you can try the next one. Where can I get the questions? Website, the website. Do you know how you get into this seminar? Through a website, right? Yeah. And then above the link that you click into this Zoom meeting, on top of that, there's some PDF file. Yeah, you read carefully, then you will be able to find it. It says like PDF or something. You click inside to the folder, then you'll get the file. All right. Nice. Done, Okay. Arvin, done? Hong Liang, done? Nerin? Wu Jun? Kang Zhen? Tian Qi, done? All right. Nerin, So here, salt P, when it is being heated, it produces MgO and a gas Q that turns reagent U cloudy. So actually, even without the cloudy, I can tell that, okay, so heating a salt and it produces one gas only. This is carbon dioxide gas. This is CO2. To test CO2, we need lime water. All right. Okay. So MgO and CO2 is come from the salt magnesium carbonate. Is that okay? Natalie, is that okay? Can Okay, then MgO react with nitric acid. So if I write my equation, I'm gonna get magnesium nitrate and water. So that means this is our magnesium nitrate. Then how about the water? These things will mix with the salt will mix with the water together to form a salt solution. So it's like the solution, the whole thing has magnesium nitrate, it has water inside together. MgNO32 plus a solution as we get MgCO3. Okay, so I have been given a product and they want me to find the reactant, so I use the cross. Because this magnesium carbonate is insoluble, so I use the N-SPA cross. Magnesium nitrate, potassium carbonate. So I already have the magnesium nitrate part, so the solution S will be K2CO3. To get the solution T, I will need to write an equation again. To get MgCO3 and KNO3. So the answer is KNO3. So it's quite simple. Okay, just like that. You see, a question like this, if it comes out in essay, just identifying all the unknowns, they already gave you 6 marks, which is a lot. Okay, then now next, moving on to the next question. In the next page, page 31. So in the page 31, yeah, you have to find all these unknown. And then Ziling, I think you can do page 27. 27. Done? Done. Hong Liang, you can do page 27 first while we are waiting for them. Okay, so mostly have done. So for this question, okay, for salts, actually it's very important to read the questions because sometimes they will hide some information in the questions, which it says solid R is formed. The solid R is brown when hot, yellow when cold. Brown when hot, yellow when cold, that's our P naught. So PbO. When it is being heated, when Q is being heated, it produces a metal oxide and a gas. The gas must be carbon dioxide. So if you plus them up together, PbO and CO2 together, it will be PbCO3. All right. Okay, then once I got my R, I just bring it down. PbO reacts with nitric acid, write an equation. Okay, you just have to write an equation. Then we will be able to get PbNO3 2 plus water. So this is what we want. Once we got our lead-2 nitrate, we react it with sodium carbonate to get lead-2 carbonate and sodium nitrate. So how do I know that which substance should be precipitate and which substance should be solution? Precipitate is always the insoluble one. Precipitate is insoluble, so lead-2 carbonate is insoluble, while the solution is soluble, just like that. Okay, done. Any question? Noah, do you have anything to ask me? Okay, then last question we're gonna do. Page 27. Last. Find the X, Y, Z, Q, R, yellow precipitate, colorless solution. Done. Done. Okay, all them done. Okay. So I start. Oh, very tired. Okay, so solid Y is brown when hot, yellow when cold. Yellow when hot, white when cold is PbO. I talk too much until I don't feel like talking anymore. So, okay, yeah, brown when hot, yellow when cold is PbO. Okay, then we can see it produces one gas. One gas is CO2. PbO and CO2, PbCO3. PbCO3 plus nitric acid, you just have to write an equation. Then you can get PbNO3 to CO2. If you still doesn't know how to write an equation, you better find out how to do it. Otherwise, GG, okay? So next, lead 2 nitrate and a reaction with a solution R to get yellow precipitate. Where we see the yellow precipitate, yellow salt, just now in the front, we did mention one yellow salt. What is that? What is the yellow salt? PbI2. Lead 2 iodide, correct. To get lead 2 iodide, which is an insoluble salt, we use N-spark. So we get lead 2 nitrate, and we also get potassium iodide. So this solution R is potassium iodide. It can be sodium iodide as well. Plus a colorless solution. So if I write a complete equation, PbNO32 plus Ki, I'm going to get PbI2 plus KNO3. So this colorless solution will be my KNO3. Is that okay? That's how we find all the unknowns. Finding reactant, we use cross. Finding product, we write equation. If it's heating of salt, then it's metal oxide and gas. Okay, can? So in the last 20 minutes, we're going to do ion test. I show you a sample question first. So it's like the one we did just now. Describe a chemical test to verify the anion in the solution Y. Solution Y is, where is solution Y? Do we have solution Y? I think they're trying to say solution X. Sorry, it's not solution Y, it's solution X. Lead 2 carbonate is insoluble. Cannot be a solution. So I think it should be the lead 2 nitrate, okay? To test the anion in the solution X, which is nitrate ion. So how should we do this? We can look at the page 13. Okay, page 13. In the page 13, these are the 4 anion tests that can be carried out. And also what you have to memorize. Okay? So if you can memorize all, of course, it's the best. If not, these 3 are the popular questions. So first, yeah, have to memorize. Basically, I just tell everything in short. Okay, anion test like that one. When we are testing anion, negative ion, I put these things into 3 levels. 3 different levels. Starting from carbonate, chloride sulfate, and then the nitrate. Level 1 is the easiest one, followed by level 2 and then level 3. So it's like level 1, level 2, level 3. Level 1, we only uses one chemical substance to test it. So the first substance that we use is nitric acid. Okay, you can also call it as dilute nitric acid. Then we can straight away get the result. When we add acid into carbonate ions, they produce bubble. And the bubble is actually carbon dioxide gas. Okay, do you have the picture here? No. Okay, if you add acid into a solution that contains carbonate, it produces carbon dioxide gas bubble, blah, 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 blah. Okay, then next, for chloride and sulfate, we also add dilute nitric acid for both. But if it's chloride, I will add another solution, silver nitrate. If it is to test sulfate, I will add barium nitrate. So you can see everything in front here is all nitrate, 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 nitrate. To test chloride, which the roti canai, we use the Persatuan Agama Hindu, Egypt. To test silbao, we use the Persatuan Bahasa Cina. Because Ag and Cl will form insoluble precipitate. That means I have a Cl solution here, guys. If I add Na plus and Cl minus, they are soluble. Soluble means they exist as a solution, so you can't see anything one. You put it into the, it's like you put a bit of salt into water, they dissolve into the water already, then you cannot see anything one. But if I add Ag plus, Ag plus and Cl minus, they are insoluble. They will straight away combine and become precipitate. So you will start to see a lot of precipitate. So that is the result I want. I want to add something into the N ion. I want to add something into the N ion and it will show changes. It will have reaction. So this is why we use silver for the chloride. All right. Both of them will get white precipitate and white precipitate. And then for the nitrate salt, we will have to add dilute sulfuric acid followed by iron 2 sulfate solution, and lastly, concentrated sulfuric acid. So you can see, level 1 is 1 step. Level 2, 2 steps. Level 3, 3 steps. 1, 2, 3. And then the first solution that we add into the ion test is always an acid. It is always an acid. The second solution we add is always a salt solution that will have reaction. Silver, chloride, barium, sulfate. Then this Fe is the ion that shows brown ring. When we do the nitrate ion test, we are going to get brown ring in the end. And the brown ring is from the iron. Okay, if I add copper, then I won't be able to get the brown ring. So only the nitrate comes with a concentrated sulfuric acid in the end. So if you ask me, can we only add nitric acid? Can we add other acid? The answer is yes, but make sure it doesn't match with the ion. It's not the same as the ion that you want to test. If I want to test carbonate, I can use hydrochloric acid, I can use nitric acid, I can use sulfuric acid, because none of the ion here is the same as the carbonate. Understand? To test chloride ion, I can use nitric acid, I can use sulfuric acid, because none of the ion here is the same as chloride. But can I use hydrochloric acid to test chloride ion? Cannot, because inside the HCl, we already got Cl minus. You are adding something have Cl into the solution, and then you tell people that, you see, you got Cl minus. Yeah. People cannot trust you. You added the Cl yourself. Then you tell me, got Cl. Of course got Cl. You added the Cl yourself. So to avoid this kind of confusion, we don't add the acid with the same ion. Understand? So if you can understand this, can you please tell me what is the acid that cannot be used? What's the acid cannot be used to test sulfate ion? What's the acid that cannot be used to test sulfate ion? Yes, the sulfuric acid. Oh. Yes. Match, then cannot. So everything I use nitric acid is the easiest one. But nitric acid cannot be used to test the nitrate ion. So I will have to replace it with another acid. And then here we must use the sulfuric acid because the concentrated sulfuric acid is the most acidic one. Okay, we want to use the most acidic acid. So it has to be sulfuric acid. Cannot be other acid. Cannot be other acid, just like that. So this is the anion test. Okay, let's do one question in the page 31 just now. Just now there's one guy came in and asked me where to get the PDF file. Once I told him where to get the PDF file, then he left the class already. So weak. Okay. So we look at this page 31. Describe briefly a chemical test to verify the anion. To test the nitrate ion. So I have to know that nitrate ion is level 3. So there will be 3 chemical for this test. So first, I will add dilute. Okay, you fill in the blank. Fill in the blank yourself. Don't refer to the front. Sorry. Never mind. Okay. Okay, here we add, when we say add dilute what guys? To test nitrate ion, we use sulfuric acid. So we add dilute sulfuric acid into test tube containing solution X. This procedure is actually not complete. You should actually tell how much acid to be added. So I doesn't want you to mark it with just add it with the pen, the blue pen you are using. If you can use a different color like red pen, it will be better. So remind yourself, you always have to mention the volume that you are going to use in the test because you are teaching people how to do the test. So I add 2 cm³ of the dilute sulfuric acid into the test to contain the solution X. Then followed by, they give 4 marks. Everything. Okay, they give 4 marks, then I put it into another sentence. So I add 2 cm³ of iron 2 sulfate solution into the same test tube. So I'll be adding 2 cm³ of iron 2 sulfate solution into the same test tube, and then I shake the mixture. So I add things into it, I shake. So after adding H2SO4, FeSO4, the last one is we have to add a few drops of concentrated sulfuric acid slowly along the wall of the slanted test tube And finally, brown ring is formed. So from this answer, it tells you that you actually have to study, you actually have to practice writing this answer when you have time. By remembering H2SO4, FeSO4, concentrated sulfuric acid, you won't be write out a full complete answer like this. Okay, so you have to practice. Practice, okay, yourself, okay? Just like that for the anion test. Now, the cation test. We'll finish it in 5 minutes. Okay. So hopefully you understand already. The method I taught you is just to help you to remember some of the reactants here. But to write the complete answer, you still have to practice yourself. Okay, same for the cation. The cation, right? We straight away go to the page 15. Same thing. Okay, same thing. We also put the way of how to write the answer there already. Okay, so now I will only teach you how to memorize this table. I will only teach you how to memorize this table. For those who know how to do this table already, like you are my student since last year, then you can leave now also. So I will be just teaching how to memorize the table. So this table, you see, there are 3 ions that come in special color: Cu2+, Fe2+, and Fe3+. They have their own color. So that means when I add NaOH to copper-2 ion, I'm going to get blue precipitate, green precipitate for iron 2, brown precipitate for iron 3. Okay. 3 specific color. Now, we want to memorize the 5 ions that usually come without color. Usually come without color. ZAPCM. Okay, we call it ZAPCM. This is how we memorize the table, guys. This is how we do it. Okay. ZAPCM. Okay. First, I will be drawing 3 lines. And then first, I separate ZAP and CM. Okay, you don't draw, You just look at how I do it. Then later you can try yourself. Okay. First, we separate ZAP and CM. We put a tick and a cross. Tick on the left, cross on the right. Okay. Then okay, near the horizontal line here, the tick and cross, because there's something we have to write on top. Okay. So now I have separated this thing into ZAP and also CM already, right? So the ZAP, I have to cut them out one by one. So first, I draw a line to separate the ZAP and AP. So that means here is ZAP, here I separate into ZAP and AP. And finally, I have to separate this into A and P. Tick and cross. AP, tick and cross. Okay, CM as well, I have to separate it. So here is CM, C and M. Tick cross. Understand? Okay, one more time. Okay, I got ZAPCM. First, I separate it into ZAP and CM. Tick cross. Now I want to do it ZAP and AP, A and P. Tick cross, tick cross. Separate C and M, tick cross. And then the observation is W, 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 4W, followed by Norway, New York. Norway, New York. NW and Y. Then we just put P into all this W, 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 N, W, N, Y. WP is our white precipitate. Okay, NP is no precipitate. YP is yellow precipitate, which we did mention here already. Okay, that's how you get all the observation. Yeah. Then on the left-hand side, okay, here is ZAPCM. Here is our SAP. SAP is sodium hydroxide excess. A is ammonia solution excess. P is potassium iodide. So if I add sodium hydroxide excess into a solution that contains zinc, aluminium, or Pb, I am going to get white precipitate that dissolve into water. That's how you read the table. All right, just like that. This is how you get the table. So for example, here, you see, add a few drops of sodium hydroxide solution. They shake the mixture, they add excess sodium hydroxide solution. White precipitate dissolve in sodium hydroxide. Dissolve in excess. So it's like, I got white precipitate, dissolve in excess is thick. By adding NaOH, so I look at the NaOH here, WP and thick, so the answer is ZAP. When I get white precipitate, does not dissolve in excess, so it's a cross in the sodium hydroxide solution. So sodium hydroxide solution, WP and cross, so it's C or M, calcium, magnesium. Understand? Just like that. So that's how you memorize the full table. 5 ZAPCM, the colored ions. Okay, then yeah, you can go through the notes or the questions to practice how to write the answer lah. That's all for today. Thank you. Bye-bye. See you next time. Bye. Goodbye. Thank you very much, guys. Bye-bye. 谢谢大家。Bye-bye. Bye-bye. Bye.